Hi and welcome back. So in this video what we're going to do, this is the 14th problem from the first signals recitation, and we're given this cosine that x of t, excuse me, sorry, is equal to the cosine of 7t minus 0.5. And what we want to figure out is what is the frequency in hertz, and also what is the frequency in radians per second. So that's the problem. If you want to pause the video, now's a good time. So anyway, the way we figure this out is remember the general form of all the cosines we have. That x of t, well, let me choose a better x of t. Well, keep it x of t, why not? X of t is equal to, in a general form, I've got a magnitude, which I'm going to call k, or I should say an amplitude, not a magnitude. I've got an amplitude of excuse me, sorry, an amplitude of k times the cosine of omega t plus some phase angle. This is the general form of the cosine that we're going to be working with. So now, hopefully you can see the first part of the problem. We've got just omega times t, where omega is our angular frequency. Our omega is in radians per second. And that's one of the things that we want. So if I've got a t here, my 7 is my omega. So that's one whole part of the problem. The next part of the problem is to remember that frequency, or if I also wanted to write this general form of the cosine, I can also write it as omega t equals amplitude k times the cosine. And instead of omega here, I can also write 2 pi frequency in hertz times time in seconds plus the phase angle. So now, hopefully you can see here that omega is equal to 2 times pi times the frequency. So therefore, if I divide both sides by 2 pi, omega over 2 pi gives me the frequency. I already know omega is 7, so my frequency is equal to 7 divided by 2 pi. And that's it. That's completely our answer. You can plug this stuff into the calculator and figure out what 7 excuse me, what 7 over 2 pi actually is. But that's it. That's all we had to figure out. And notice we didn't use any of the phase information. Let me write that up here. We didn't use the phase at all. The phase, if I have some phase shift in a cosine, it doesn't affect what my frequency is. So notice that minus 0.5, it didn't matter at all. Our omega is 7. Our frequency is 7 over 2 pi. Oh, and I should also say this is 7 over 2 pi hertz. And that this is, let me actually rewrite this, as omega is equal to 7 radians per second. So we have all the correct units. Anyway, that's it. Hopefully you found that useful, and I'll see you in a future video. Thanks for watching.